Hi there. Today we are talking about the higher order functions. Higher order function, which is like big fish eat a small fish. First, let's create a playground. So we create a playground name half playground. Create and remove the default statement. So higher order function. We create a function of big fish func. It takes a parameter of integer, b of integer, and the third parameter we call it operation, which is a function, and the function signature it takes two int, return int type, and big fish function return int type, and the statement will return operation, which takes that a and b as parameter, and the operation which is that small fish function. So small fish function will be take x as integer and y as integer, takes two integer, return an integer, and its statement is return x plus y. And we can say we want the result, let the result equal to big fish function. We call big fish function, and the parameter a is 5, b is 3, and the operation, which is the function name with small fish function, small fish func. And so after run the big fish func, and it got the result 5 plus 3, 8, and the small fish function, which is that function passed to the big fish function as a parameter. So, and the operation is s plus, and we can make the code need to be more concise and readable by replace the small fish function with closure. So the closure is a function without function name. We can and without a func keyword, and we remove the curly bracket to the very beginning of that small fish function, and the curly bracket we removed, we will replace it with the keyword in, and that's a closure. So now our big fish function looks more after replace it with a closure, it's more readable, and we don't need the small fish function anymore. We can just use the closure, and the closure, you can see it's in a curly bracket, and after the function signature, it has a keyword of in, and then the statements after the in we have the statements. We can remove that function. Actually, we replace with that the closure. We can simplify the closure. First is the function. The third parameter of function is a closure. We can remove that in the big fish functions parameter, and we inside and remove it the in and the in keyword, and remove the return. And because if it's only one statement, we don't need a return. And the closure can have the default parameter, which is $0 and $1. So after we simplified code, the we called big fish function just like the statement will be $0 plus $1. So it's simplified closure because the operation is a function and Swift can know that is a closure, which is and $0 and $1, which is the default parameter, and Swift can know that the parameter type is int, because that's what the A and B, which is int type, and Swift can know the int. The common higher order functions which mostly used for the collection like array and dictionary and so on. It has map, filter, reduce, and sort. So first, let's say the map, like squared equal to numbers dot map. Map is a higher order function, and it needs a transform function. So let's create a transform function like a transformer, and this is square for square, and so it will take int parameter. So it's a function. I take a int parameter, which is, let's say, number and num, and type of integer, and return integer, and the function will return num plus num. Okay, that's our transformer function, and we can pass the transfer function to the higher order map. So we pass the transformer square to map higher order function, and you can see the numbers dot map. The first parameter is underscore, so that means we don't need to specify the parameter name, and we just put that transformer square and as the parameter of function. And so we can replace the transformer square with closure. So let's just say replace it with this function with a closure. We can say curly bracket closure, which is inside of curly bracket, and our curly bracket, our parameter list and return type. We don't need a function name anymore, so we got the parameter list and return type, followed by in, the keyword of in, and we say return num plus num. Return num plus num. This is our closure inside of the map higher order function, and the numbers is array of integer. So each element Swift can infer the type as integer. So for this, we don't need to specify the closure's parameter type, so we can remove the int, and we can also infer the closure's return type is integer, so we can remove the return type. By know the parameter type specified, we can remove the parentheses for the parameter list. And because in the closure we only have one statement, we can delete. We can remove the return. So that's our numbers map higher order function, which has closure as inside of the higher order functions as a parameter. And we can say, because we can use inside the closure, we can use the default parameter instead of specify the parameter name, and in we can say $0 as the default parameter for the closure and plus $0. So inside the closure, we got the closure which has $0 plus $0 instead of specify a parameter, and in we use default parameter. And because there are no more the parameter, we can remove the parentheses for the higher order function of map. And that's finally we got the squared equal to numbers.map and the closure $0 plus $0. And remove those. That's the squared, which use the arrays map function. And we got 2, 4, 10, and 6, which is the square value of each array elements. Let's say light filtered, which equal to numbers dot filter, and the closure is $0 not equal to 2. So we filter the element which value is 2, and we return, then the array will return 1, 3. And 2 will be filtered. The reduce, which will let's say we will add each elements together and return a single value, the reduce. So the parameter is 0, and the closure will be $0 plus $1, and we return 6, which is 1 plus 2 is 3, and plus 3 is 6. So the reduce. And sorted, we can say we change the numbers 1 to 5, 3, and we want the numbers dot sorted, and the closure will be $0, the first default parameter, less than $1, the second default parameter, and we will sort it in ascending order. And then we can see after sorted, we can see 1, 2, 3, 5 instead of 1, 2, 5, 3. So the numbers array is sorted in ascending order. And that's the common use of higher order functions.